Hi, this is Ashokan. I welcome you all to understand how we can use Wireshark for packet analysis. This is the first screen of Wireshark where there are a lot of files which have already opened and you have a lot of interfaces connected with this machine. And if you go to the help and about the Wireshark, we will understand what is the version of this Wireshark. It is 2.4.1. 2.4.1 is the new version. You will see a lot of other details on which machine it is running, what is the operating system, i7 with 16 GB RAM. A lot of other details you will be able to get here. Now let me click on this Wi-Fi adapter. This machine is connected with the internet, and let me browse some site so that I get some traffic. I say yahoo.com. and then I say rediff.com, maybe I can write youtube.com, and once I browse I will see that some data is being captured here. 4,950, 5,000, 5,400, 6,000, so many packets, as we don't need this at this point of time. And there is a red button. I click on that so that the capture is stopped here. You see at the bottom here there's a statistics, how many 7,296 packets and 7,296 packets are displayed here. And as far as the by default installation of Wireshark is concerned, there are three windows. First is the main window, and second is the detailed window, and third one is whatever in the detailed window, wherever you click, the hex portion of that will be displayed here, and the ASCII portion of that is there on the right side. For example, if you go to the internet layer and if I come down, I see that there is a source address and the destination address. The source address say, the hex portion say that 1, 2, 3, 4 bytes of space, which means 32-bit is the IP address. This is the space it occupies here. So like that, if you click on any packet there in the main window, you will see the details of that packet here in the detail window, and this is the hex portion and this is the ASCII portions. Every parameter in this middle window is very important for us to understand. Let me take you to some slides so that we can understand what all the things we cover in the Wireshark course. Packet analysis with Wireshark. Capturing packets, select an active interface, saving the captures to a ring buffer. It's a methodology to capture the files. And once you use this ring buffer methodology to capture packets, only then you will be able to work with the file sets. Both are linked. There are a lot of capture filters and display filters. Capture filter means you set the filter before you capture the data. For example, if you use a capture filter for capturing the, say, the DNS packets of a communication, you will get only the DNS packets captured. That is what capture filter is for. But the downside is, later if you want the TCP communication or any other packet or the application packets, you will not be able to get out of this. Whereas the display filter is totally different. When you capture the entire packet, maybe you have 6,000, 10,000 packets here. Out of this 10,000 packets, if you want to filter DNS, then display filter will help you out. So we need to always, it is better to use the display filters than the capture filters. Configuring the global preferences is the next one. You can configure the Wireshark for global preferences, and in that you have the name resolution, and you also have colorization techniques. Let me take you to Wireshark and show you where this global preferences will be. In this Wireshark, we go to edit preferences. See that there are a lot of layouts, column, fonts and colors, captures, filter buttons, name resolution, so many things you can configure here. Wireshark is something like a clay. You have to set all these parameters in order to use Wireshark as a tool in the environment. Next is the colorization technology. So there is color. I disabled this. If you want to color, if you want to give a color to a specific traffic or specific filters, you can go to the view coloring tools. Already Wireshark has given some colors for, say, BAT TCP, this foreground and background, and for ICMP, this background and foreground. You can even change anything here. If you click on this, then you can change the foreground colors as well as the background colors of your choice. And if you want to add something, there are 3 buttons here. If you press this plus button, you can create something new here at the beginning. You can something new, or if you press the second button, then you can delete that also. This is to copy whatever you like. If you wish to copy that, then you can click on this particular button. I cancel this. Let's go to the slides. In the next slide, we understand what is navigation. You can go to specific packet number. Suppose if you have 5,000, 6,000 packets captured, from 10th packet you want to jump to 3,000 packet, then you can go to a specific number of packets, specific number. You can jump between packets. You can find the packet based on the payload value also. Payload value means maybe yahoo.com or google.com, that particular keyword you can give. If such keywords are there present in any of the trace, then you will be able to get that particular packet instantly. Sort the columns, mark packets, show packet in a new window, all these are the navigation techniques. Time values is very important. Time values and summaries use default time column and settings, precisions, and time precisions. I'll show you how the precision will work. And time between packets, set reference view. So these are the time values here. If you go to view display format, there are seconds since beginning of capture, seconds since previous captured packet, and you will get like this. And the precision is, if you go to the say automatic from the capture, you will see that the time precision is 3.1, 2, 3, 4, 5, 6 digits. This is what the precision is. If you want to minimize this, you can configure it, view time display format, and there are 10th of a second, 100th of a second, milliseconds. If I choose this milliseconds, you will see that packet only in 3 digits. This is millisecond, which means that 0.002 milliseconds, 3.852 milliseconds. So the precisions can be given time display format. You can configure here automatic, and you have other settings here, view time display format. All these seconds since beginning, previous captured packet since beginning, and previous displayed packet, these are various meanings. You will get a different display as you choose each one of this. This is very important for us to understand the time delays of the communication between a request and a response. Whether there is any delay or not, we can measure only with this time values. It's very important in Wireshark. Understanding the packet structure. The following pages, we have a lot of packet structures. In that, we will see each one of this, the filtering, how to filter on the specific traffic, how to analyze the normal and unusual traffic, and you can save and export and print or save filtered files. So filtering is very important. Then you can mark the range of packets also, as well as you can export packet information. Every packet information, detailed information can be exported into a specific file. You can have a text file or you can have other formats. In-depth analysis of protocol structure. We are going to analyze in this course, analyze address resolution protocol, ARP protocol, gratuitous ARP, and ICMP, UDP, DHCP. Next page if you see the DNS traffic and the TCP, and analyze the TCP resolution process and the internet control message ICMP, IP version 4 HTTP, literally every common traffic what we use, we are going to analyze in depth, which means every packet we will open and each and every line has to be studied, why it is and what are the various parameters belonging to a protocol and how we can use those parameters to filter the traffic or to isolate any troubles there. Let me show you as to how to filter the traffic, a sample to filter the traffic. Let me go to the Wireshark. So here, if you understand the protocol very well, see there are a lot of DNS packets here, DNS query and DNS responses. If you see the statistics, 7,296 packets, out of that 7,296 packets, like 100% packets are displayed here. Out of this, I need to pull out only the DNS packets, which means I need to have a filter here. Say DNS is the filter string to filter the traffic. I say enter. I get only the DNS related packets here. Only the DNS related packets. And out of 7,296 packet, 287 packet, 3.9% is displayed is the DNS packets here. I go to the DNS query packet. There is something known as DNS flag. If you expand that, you will see the first bit here, it is 0. If it is 0, that means it is a query packet. The first bit, if it is 0 in a DNS flag, it is a query packet. The first bit, if it is 1, it is a query response packet. Let me go to the response here and see that the first bit is a response packet. Now, in this response, if you come down, there are a lot of things we need to understand here. At the end, you will see a reply code, an error code. If there is a DNS error, there will be numbers here accordingly. And these are the various filters, filtering parameters you can use for filtering the specific traffic. For example, this is 1, it is a response packet. I'm going to filter out of this 287 packet which contains the query and responses. I'm going to filter only the response packet. So I right click here and I go to the prepare a filter and apply a filter. Both can be done, but I go to the prepare a filter and select it so that I can show you the filter. So once I click dns.flags.response equal 1, I can change this equal 0, so you get all the queries, and equal 1, it has all the responses. I say enter, we see that all the responses we are able to get now. And what is the size? 139 packets are the DNS response packets. The next line says that looking at various features, we have number of features with Wireshark. Some of them is mentioned here. Reconstruction of the browsed image, whatever the images which is crossing on the wire, we can reconstruct it. We can create display filters, and the follow TCP stream will tell you what is the TCP stream or the stream of communication between a client and a server. Create filters from conversation and endpoints. Out of so many conversations, we can pull out a single conversation in Wireshark, which is a very handy feature to understand communication between two systems or a system and a server. Default display filters and filter syntax. You can create filters using any parameter. You can combine the filters also. A combination of filter also will serve the purpose of filtering the traffic to a specific desired goal. Troubleshooting lab. This is very important in the perspective of a person who completely wanted to handle the packet analysis with Wireshark. Creating troubleshooting profiles and follow TCP stream, creating IO graph. You can create various types of graphs, default display filter and syntaxes. You can build and save filters. Build and save filters means you will build the filters and you can save that also for later purposes. And the delta time value, again the time value is very important. Analyze expert information. This is one handy feature of Wireshark, which will provide you a complete bird's eye view of the errors in the capture. So I remove this filter now. I go to the analyze expert information. The expert information says that the errors, warning and notes. There are three types of errors, warning and note. The warning say the previous segment is not captured, there are ignored unknown record, there is acknowledged unseen segment, and what are the error here? If I expand, you will see that there are spurious retransmissions and various types of retransmissions we will discuss in this. And other warning is this frame is suspected out of order segment. All that error in this capture will be able to see here at the export information. The beauty of this is that suppose if you want to go to a packet number, say 2051, you are in packet number 1346 now. If you click 2051, you will be taken to that directly, and from there you can analyze what is the problem with that. So that's a very handy feature. It is analyze expert information, you get the screen. Instead, if you want to go to a shortcut, at the left bottom corner there is a button. If you click on this button also, you will be taken to that particular screen for quick analysis. The troubleshooting labs continues. The round trip time, three-way handshake. Is there any delay in three-way handshake round trip time? So where the delay actually incurred, and what are the various causes of the performance problem, and the network fault where it will occur. What are the TCP resolution process? If you understand the TCP resolution process really, then you can pinpoint where the problem could be. For example, there is one system and another server. When you take the browser and say www.google.com, enter, and the page is not displayed here, the page is not there. So we cannot say because from the application to application, the application is not working. We cannot pinpoint that. If this particular machine is not resolving the DNS, still you will not get the page. So where the problem really occurs, if you want to understand, you need to understand the TCP resolution process. DNS errors and error codes, HTTP errors, all these errors we can find out pertaining to any protocol, and we have to have a powerful filtering system for that. How to filter the data? What are all the various parameters? Parameters in the sense, let me take you to Wireshark. Suppose if you click on any line, the entire OSI layers you will be able to see here. The transportation layer and the IP layer. You get the IP layer here. And all these are the Ethernet layer and the IP layer and the transport layer, and if it is a packet which is an application, you will see the application layers, and all that, each and every layers. When you click on that, when you open that, you get a lot of parameters, and the parameters which is mentioned in the square brackets are not part of the protocol. It is the interpretation of Wireshark, not the part of the protocol, but that also can be used as a filtering criteria. For example, window size 334, it's a very low window. If you want to find out, say apply, prepare a filter and select it, you can say TCP dot window size value, say less than say 200, which means if I say enter, you will see packets, how many packets? 4003 packets which has a window size less than 100. This is, you can filter the traffic lights, and you can very easily find out what is the problem going on in the live network. The next slide say the filtering latency issues and time data filter, troubleshooting with the time. This is also very important, the time factor in Wireshark. Packet loss and retransmission, why retransmission occurs, what is retransmission, what is spurious retransmission, all these various retransmissions we need to discuss here, we will discuss here. Packet loss and recovery process will be discussed, locating the buffer problem and the zero window condition. This is also very important. Let me show you what is this zero window condition and window update process. Let me modify this TCP dot window size value less than 200. There's a previous, I say it's equal 0. Say enter. See that so many packets, 82 packets out of 7296 has a Windows 0 value, which means if you go to the transmission control protocol, it says that window size is 0, which means This client system says, I have no buffer to receive any data. Please stop. That is what the window size value, window 0 condition. When a client system is talking to a server, this is the server, and it is requesting some web page or some data, the server is sending some data that is saved in the buffer space of the client system. This is the buffer space of the client system. The application has to take the data from this buffer space. Because the buffer is full, this machine enter into a zero window condition. This will not be able to accept any more data from the server, and it says a zero window packet here so that the server temporarily stops sending data to the client. When this application is very slow or the application is not taking data from this, then this condition occurs. When the application start taking the data from here, what happens? There will be gradually space available in the client's buffer space. When the buffer space is available, it will say that yes, this much of buffer, suppose if it is 1000 KB, and it will send something known as 1000 KB is available for me to receive the data, that is in the form of something known as window update packet. So the zero window condition and the window update packet is the resolution process. This is how if a system got into a out of buffer space, that is zero window condition, this is what the recovery process. So zero window condition and the window update packet. And the next lab, lot of lab we conduct like this, IP fragmentation packet. IP fragmentation occurs at the layer 3. The IP is fragmenting the packet. Segmentation is done by the transport layer. Out of order segments, filtering problematic packets. If you find a packet problematic and find out the specific parameters, and using the parameters you can filter such packet alone and show on the screen. Understanding retransmissions, as we already discussed. Filtering traffic based on port number as well as other parameters. Creating filter expressions, but you can create a filter and save that filter also for later use. Change the dissector behavior. We need to configure the Wireshark also, how to measure the HTTP response time and other such features very accurately. Let me take you to Wireshark to show one example. We are in the transport. I click on one link here and I go to the transport layer, and in the transport layer if you right click and you get lot of preferences here. This preferences will say allow subdirectors to reassemble. You can validate the checksum if possible, and normally there is a lot of things we need to understand about checksum, because normally Wireshark offload the checksum calculation to the NIC card driver. There is relative sequence number, the scaling factors, and calculate conversion timestamps. A lot of things we need to. So these settings affect the very calculation of the download time. So all these we need to practically download and understand. Then it will be really helpful to access the packet in the environment. So change dissector behavior. This lab-oriented program is offered online and offline. Those who wish to learn through online may contact me at wiresharklabs@gmail.com. Here is the Gmail. This is Asokan signing off. Happy learning. Thank you very much.